So, deep in the ocean is a denizen of nature with the most complex eyes in the world, who hunts with the ferocity only it could endure. It is the basis of $7.5 million of research by the Air Force Department of Science. It is the mantis shrimp. So, how this could influence your lives. It could be used in the future to inspire the next generation of material science, which could develop body armor. It could develop plane material or car material that is more impact durable to save lives. And also, its unique eye structure could perhaps influence vision science. Today, I come with you after a week of research from claimed sources such as biologist Michael Bach, Ms. Ilsa Dali, and Dr. David Casalis of California at Riverside. There are two things that I will be talking about today. One will be its eyes, and the second topic I'll cover that's unique to the mantis shrimp is its dactyl clubs, which are the scientific term for its claws. As for the eyes, they're unique in multiple ways. First up, they have not the three photoreceptors that humans have to perceive color, which is red, blue, green, and we can perceive all the combinations of those. It has anywhere between 12 and 16, depending on the type of mantis shrimp, which far usurps the second most photoreceptive animal in nature, which is the butterfly at 5. So it by far outshines in colors that we cannot perceive the butterfly and us. And that is according to the biologist Michael Bach in his 24 article, Biological Sunscreens, Tune Polychromatic Ultravision, or Ultraviolet Vision in Mantis Shrimp. In the same article, he goes into how 6 of those photoreceptors are dedicated to UV light. So this creature can perceive UV light, ultraviolet, that we cannot. And it does this in a unique way. It has 6 photoreceptors dedicated to UV light. So usually this would mean it could perceive 6 different, it would possess 6 different opsins, which is just a chemical found in the eyes to perceive light. It would have 6 different opsins to perceive this different spectrum of ultraviolet. But it only has 2, despite having 6 photoreceptors dedicated to it. So that is a unique system, by far the most complex UV perception in nature. And it does this by filtering the ultraviolet to the proper photoreceptors and opsins, which is a unique cueing system. In addition to this, it has 3 degrees of rotation in its eyeballs. It can move up, down, which is 1 degree, left, right, and it can also roll in the eye socket, which produces an odd visual sense, similar to us turning our heads while trying to track a moving target. This is unique. Most creatures avoid moving their eyes so much as to avoid motion blur and not being able to track their target. However, due to the sheer amount of photoreceptors in the eye, it actually has a harder time distinguishing between colors. And it's proposed by Ms. Ilsa Dali in her 2018 article, Proceedings of the Royal Society B Biological Sciences, that it uses this unique satellite-like vision to track the targets despite the overwhelming pressure from its photoreceptor. After talking about how impressive its eyes are, it's kind of unfair that would have yet another shining example claim to the throne in Animal Kingdom, but it does. These clubs, the dactyl clubs that I referred to earlier, they're pretty great. In a single second, in fact, most times under a single second, they can reach speeds up to 50 miles per hour with the force of acceleration of 10,000 times gravity. This is so fast that it can replicate a .22 caliber bullet in its force, and actually boils the water around it and releases a second impact upon the implosion of a jet of bubbles on its target, which is used to hunt hard-shelled prey like crabs, lobsters, and snails. And this is via the Weaver et al. 2012 article in collaboration with David Casalis that I mentioned earlier. The Stomatopod dactyl club, a formidable, damage-tolerant biological hammer. Now, with all that force, it would stand to reason that the dactyl club would suffer some damage, but it doesn't due to its unique herringbone structure, unique to the mantis shrimp in nature, that distributes the stress so well that that is the basis of the research done by the Air Force Department of Science into the next generation of material science. To recap, the mantis shrimp is unique in two biological ways. Its uniqueness with its eyes, the most perceptive in the animal kingdom, and its clubs, the most durable in the animal kingdom. When you think of creatures that may change the world, you may not think of shrimp, but I would keep your far less complex eyes on this shrimp, for he could just revolutionize the next age of material science.